He's doing. All right. Wow. I don't see. Where's Justin? This one's again?
I don't think it will. I don't know.
Nothing. Yeah.
Yeah.
See? Yeah, I don't know why. And why?
Oh, nice to meet you.
Put a name to the.
Yeah. Yeah.
I really. Yeah, not really. This whole he's doing that.
Yeah.
It's kind of.
Okay.
It feels like.
Gotcha. I think I kind of.
Yeah, 'cause I sent you the file and I was like.
I
Yeah, I'm gonna change it after. Now you know.
Yeah.
I was like, what class was it?
Yeah.
Excited for the class. Is it the design?
Yeah.
Machine design.
On Finite, I'm the president.
Oh, yeah.
That's good.
Yeah.
Oh, I see. Oh, nice to meet you. So, yeah. Some constraints this semester. We normally try to activate possible. As of right now, I can say relative certainty that's top five. But beyond that, I can talk to the teachers. We are facing some challenges this year, as you know, certain electives and certain time. And so I think. I do know that. The top five, I'd say you're not, you're outside top five, you know.
You got called out.
Okay, cool, perfect, good. Okay.
Like.
Oh,
It's like yeah, I am. Oh, yeah.
Oh, really?
Oh, also on Thursday, we need to clean out the trailer. Thursday.
Dude, I actually better not yes, at least. I think there's a fire like this coming. That's John's trying to scale there. That's police on the back.
Oh, yeah.
Yeah.
That's here.
People, you know, watch all the things. Yeah. You came into the room with like.
I still have my tickets, right?
Yeah.
You want some leaves, right?
I'm kidding.
They're like,
No.
they're 2 days. That's our team.
People that.
So my senior design is on Friday.
I love you. I appreciate it.
This changes the narrative.
Is there another one?
Oh, are you in?
They're also like seven. That's not like a hard ass.
Nice to put a name. Oh, I didn't know you were in class at 8. One hike so far, right? Oh, I've done multiple.
I feel like, yeah, I'm like 5 minutes.
You practice Steve on the 20.
So I
Oh, nice. It's not rice, it's not the, I don't think so.
It's not a-
You're not gonna get.
I was just telling you.
That's a lot too.
That's the first sign with him.
I didn't want to face what we like.
Yeah, very true. You don't have to do a lot of shit.
So mad.
Others can see like.
I think
I don't know why.
Oh, really?
Oh,
yeah.
Yeah.
People secret around me.
I did not know.
You shouldn't be talking.
But it does, no, you should be able to.
Chino manufacturing.
I think it's one that I
Block line on.
I think it was hard, like it was sweet.
The girl that you.
So.
Yeah, that's okay.
We're not talking about. Really?
I don't know the name.
I wanna hear it.
All right, it's 5:30. Let's go and get started. Good afternoon, everyone. How's everyone doing today? Good, good. Nice to see you. How was your summer? Everyone have a good summer? Good. No, okay. Well, hopefully the semester is better for you guys. All right, so my name is Professor Justin Tran. So I am the instructor for the course. You guys are sitting in EGME 410, Introduction to the Finite Element Method, Finite Element Analysis. It's all the same thing, okay? So today is our first lecture. And so the plan for today, I don't have any actual content today. And we're not doing ANSYS today. I know everyone's eager to do ANSYS. I get that question all the time. When are we doing ANSYS? When like we're gonna do fucking ANSYS, okay? Just relax. Just not today. We're gonna do it on Thursday, okay? So today I'm just gonna introduce the course just to tell you, what finite element analysis is, what you can expect from the course. We're gonna go over the syllabus. We're gonna explore the policy, the office hours, all that good stuff. So today's just kind of administrative stuff. You can just kind of sit back, relax. Don't relax too much. I want you guys to listen to what I'm saying, but don't stress. Today is a zero stress day. Okay? Actually, before I start, I do want to address something. I know that a lot of you guys are on the wait list. I've already kind of spoken to a lot of you guys about the wait list situation, but basically what I'm telling people is that we are kind of working with a lot of constraints this semester. Normally for this class, you may have heard from previous year that, I pretty much accept everyone from the wait list. I don't know if I'll be able to do that this semester. We're kind of facing some constraints at the department level. There's also a lot, I have a lot on my plate this semester too. There's a lot I have to do just on the administrative side. So I don't even know if I have time to really accept 50 people into this class. So if you're on the wait list, I'd say, if you're top 5 right now, I'd say you're pretty safe to be added sometime next week. Beyond that, I think that's a conversation we're continuing to have with the department. So if you're kind of beyond number 5 on the wait list, of course you can stick around. But I would also start to maybe consider other technical electives as well if you need something for this semester. Okay. Any questions on that kind of situation right now? so a little bit about myself. So my name's Professor Justin Tran. I just mentioned that just a minute ago. My office is in the engineering building, so I am in engineering 220. So that's the second floor of the engineering building, same floor as the big lecture hall that we have there, just just right down the hall. My email address is justran@fullerton.edu. Okay. It looks like the email address of some running club here, but it's just my name, Justin Tran. They just took out images for some reason. Okay. I'm pretty local here, so I grew up in the area, so I came to Fullerton all the time growing up. I used to go to that Mazer Quest in kind of off Lemon, off the 91 all the time with my friends. So I'm very familiar with the area. A lot of my friends went to college here, so I love being here. Okay. I've been in California my whole life. So my bachelor's was at UCLA, my master's was at UCSD, PhD from Stanford, all in mechanical engineering. So California, I've been all the way up and down the coast. Okay. My research interests kind of are a little bit adjacent to this class, but I'm interested in basically how can we apply engineering tools towards studying, heart and blood disease biomedical applications. Okay. So one of my main focuses of my engineering of my research is how can we apply finite element analysis, finite element simulations to studying heart and blood and all that good stuff. Okay. And of course, just by the nature of my job, just being a STEM educator, I'm always interested in better ways that we can redo this stuff. Okay. So I know there's a lot of familiar faces in the room. I recognize a lot of you. So a lot of you have probably seen me before. So if you've had me as an instructor before, I love my learning objectives. So at the beginning of class every day, I always post the learning objectives for the day. Okay. And so it'll be usually a bulleted list of anywhere between 3 and 5 items on there. So you can think of these learning objectives as kind of an outline of what you can expect to cover for that day. Okay. And so I always tell people, you come in, I try to come into the lecture about 15 minutes early, so I'll have these up 10, 15 minutes before the lecture starts. So write these down in your notes. If anything, it helps kind of organize your notes a little bit. So we're using a lot of notes in this class. So having something like this to kind of summarize what a certain section is about is always really helpful. Okay. But if you kind of read these carefully, I kind of structure these in a very particular way as well. You notice that every single one of these objectives here starts with verb. Okay. And so, for example, the first one that I have there is to describe the use and utility of finite element analysis in engineering. Okay. I do this very intentionally because I want to give you guys an idea of what you should be able to do after this class, right? Because you guys are in college, you guys are here to learn, and so you guys are here to learn skills that you can use to demonstrate to employers, to impress your girlfriend or whatever, so I want to be able to give you a promise in terms of what you should be able to do after every class. Okay. So the learning objectives are always kind of structured in that way. So they start with the verb, because they should be some kind of actionable or demonstratable kind of thing that you can do. And that kind of serves as a good way for you to kind of assess, how well did you learn things from that lecture, right? And so let's say that we just finished a lecture, and so you're looking back at your notes and you're saying that, all right, one of the learning objectives for today was to describe the use and utility of finite elements. If you can do that, if you can come, write a couple sentences to describe the use and utility of finite elements, then that's great. Then that's one really important point that you got from the lecture. But if you're not able to do that, then maybe that's an idea. Maybe you should go back to the notes. Maybe you should talk to me, send me an email. Hey, I didn't really quite get this learning objective, and we can kind of go from there. So it's kind of a way for you to kind of self-assess, kind of give yourself feedback in terms of how well that you're obtaining the knowledge. Okay, so let's get into the course. And so this course is all about finite element analysis. And so you'll hear me call it FEA or FEM throughout the course. Okay? So what is it? And so what is finite element analysis, and why is it important? I think for a lot of people in this class, just because I've taught this class for quite a few years now, I think when people think of finite element analysis, they think of ANSYS, right? So they think of the software. The software ANSYS is really just kind of an implementation of the finite element method in general. Okay, so because when you think of what finite element analysis actually is that it's a numerical technique for solving differential equations on arbitrary geometries. Okay, and what it does is that it leverages computers to perform arithmetic and calculations that are
at speeds way beyond what's available to the humans. Okay. But at its core, actually, FEA is not itself a computer thing. It's actually a math thing that just happens to work really well with computers. Okay. We're not going to get too much into the theory of this class. This class, we kind of more focus on kind of the application through ANSYS. But just know that FEA is really kind of what's called a numerical technique for solving differential equations. Okay. And why do you ask, differential equations are so important? It turns out that a lot of physical behavior in the world, their behavior is modeled or the behavior is governed by these differential equations. Okay? So you think of something like fluid mechanics. So fluid mechanics, a moving fluid is determined, its behavior is determined by the Navier-Stokes equations. You think of a thermal situation, we have the heat equation for that. All of these are differential equations. Okay? And so kind of the unicorn for engineering analysis, that if you can solve differential equations, you can really understand and analyze a lot of physical systems, because almost all physical systems their behavior is governed by differential equations. Okay. The difficulty with that is that differential equations are really freaking hard to solve. And so you guys have already taken a couple classes of that. So Math 250B 308, right? In those classes, you're given kind of the simplest ODEs to solve, baby's first ODEs, right? And even that was already really difficult. So if you can think of solving more complicated differential equations on even more complicated geometries, you really need some help to do that. And so finite element analysis is kind of your way to do it. For the most part, as a user of FEA, you never really see the mathematical side. You kind of just see the graphical interface and the stress distributions, things like that. But just know that underneath the hood, your computer is solving these really complicated equations for you. All right, so why is it important? So how do we use finite element analysis in engineering? So FEA really has become almost like, I would say it's pretty much an essential part of the engineering design process nowadays. Okay? Because what it allows you to do is that it allows you to design and analyze engineering systems with geometries, loadings, and boundary conditions that are too complicated to perform hand calculations. Okay. And as it turns out, most practical engineering systems kind of fall in this category, right? No one is really getting paid to design just a simple cantilever beam. And so all the money really is being made towards designing these very complicated structures, these very complicated systems. And with such complexity, you really need a computational tool like FEA to kind of help you. Okay. So FEA kind of falls in the branch of engineering, which I call analysis. Okay. So analysis is really, taking a system, predicting its behavior, and computing quantities associated with it. Okay. And so when you talk about analysis, there are kind of three categories of analysis that are out there. The first type of analysis out there is what I call analytical, which are what I call kind of pen and paper calculations. So these are kind of what you're accustomed to in your typical solid mechanics, fluid mechanics, heat transfer courses. So these are kind of all the problems you work on by hand. Okay. So these are typically very fast and inexpensive. So all it requires is just a pencil and a paper and your imagination, I guess. But these are limited to very simple problems, right? You can't really do any kind of really complicated engineering with pencil and paper. Okay. The second approach to analysis is what I call experimental. Okay. And so if you want to get information or you want to get data in terms of how a physical system behaves, the best way to do that is just to go out and try it. Right? And so if you're curious if your car can survive a crash by crashing into a tree, well, the best way to do it is to crash your car into a tree. So you can run all the simulations you want, but the best way is to go out and try it. Right? And so experiments, I always say this is always the best way to get data because there's no disputing it. It's because it actually happened, right? So you set up an experiment, you observe it, and it actually happened. No one's going to question you on it. Okay, so the data that you get from experimental setups is always the best. Okay. The downside to this is that setting up an experiment can often be very time consuming. Oftentimes you have to do a lot in terms of setting up the measurement probes and make sure everything is in place and things like that. And it's very costly, right? It's fun to say that I'm going to crash my car into a tree to see what happens. Paying for a new car is not as fun. So. And if you kind of apply that to like an aerospace company where, if they want to find out if their airplane's going to crash, buying a whole new airplane is something that your manager is not going to be very happy with. Although it seems like the people at Boeing kind of seem okay with it. So the third approach to analysis is called computation. Okay. And so computational approaches kind of have a similar approach to analytical, in that, we are at the end of the day, we're solving equations, right? But, with computers being able to run calculations very, very quickly, we're able to do it on very complicated, situations. Okay? And so, the idea with computational is that we kind of get the best of both worlds, where it's fast, it's relatively inexpensive, you just need a computer for it. And with the computing power for computers, you could handle, as almost as much complexity as you can handle in terms of the geometry and boundary conditions. Okay. So that's kind of the space where FEA kind of operates, is that, we computational analysis, it's fast, it's inexpensive, you don't have to make prototypes for it, it's all in your computer. So it's inexpensive in that way. The downside to computational approaches is that it can be very tricky to set up. And there are a lot of pitfalls that you can fall into in terms of setting up an analysis the wrong way. And unlike analytical and unlike experimental, you could set up your simulation completely wrong and get completely garbage results. But the computer often won't tell you, right? So you need to have some good know-how. You need to have some good knowledge in the tools to really discern and make sure that your results are reliable. That's kind of what we're going to be doing in this class. Okay, so let's do some examples just to kind of illustrate kind of the utility of that. So let's take a very simple beam analysis, right? So I have kind of a very simple one-dimensional beam right here. It's simply supported. We have a distributed loading on top. Okay, so a situation like this, you can probably solve it by hand, right? So if I were to ask you to to solve for the deflection in the beam, how much is the beam going to deform as a response to the loading? You should be able to solve the beam equation to give me a functional form for the deformation of this beam. Because again, this is a relatively simple situation with simple boundary conditions. But if I were to tell you to perform analysis on a very complicated structure like this, with lots of different beams and lots of different levels, things like that, you wouldn't be able to do this by hand. You would need to get help from a computer to do it. And that's what FEA allows you to do. Same thing with heat transfer. So let's say that you were tasked with solving for the temperature distribution in this kind of slab right here. So if your situation were kind of as simple as this, you can solve the heat equation for this, and you'd be good. But if I were to ask you to solve for the temperature distribution in this turbine, right, which is spinning, which has hot air blowing at it, right? Very, very complicated loading, very complicated, conditions. You would need to have some kind of computer software to. But even in this kind of small geometry, you can see that we have very sharp, differences in terms of the temperature between very, very hot here and a cooler at the tips. Okay. And probably the application that's probably nearest and dearest to me, which is fluid mechanics. So. Kind of the most simple case that you have here is that if you were tasked with finding the velocity distribution of flow in a pipe like this, you could do that. You could solve Navier-Stokes in a simple situation like this. But if I were to tell you to solve for the velocity in something like this, where the geometry is really complicated, and you have kind of almost like an injector jet that's being applied here, that's going to be pretty complicated. This picture, this image in particular is actually an image from research of a colleague of mine, where basically he was researching ways to improve surgical outcomes for these patients. Okay, so this right here, these are the blood vessels inside a person's body. This blood vessel right here, you can kind of see where the flow is kind of coming in like this. That normally doesn't exist in a person. But what my colleague was proposing was to insert a blood vessel there. And that's mostly there to help the flow for patients with a single ventricle, single or only half. Okay. So I'd like to tell this story because it's kind of the classical kind of really best case scenario for where simulations and FEA can really help. Okay. Because the benefit of a digital platform like FEA is that you can try out new designs, and it's very, very cheap to do so, and you kind of see the result of your design in the computer kind of very quickly. you know, for most engineering companies, that kind of just translates into saving money, right? So it saves the company money from having to purchase a prototype, you know, and all the time consuming ways for that, okay? But when you're talking about biological systems, it has an additional cost as well, okay? Because let's say that, you know, you go to the doctor and they tell you that you have a heart condition, right? And so, you know, the doctor comes to you and says, you know, I've been thinking about this new treatment, but I'm not sure if it's gonna work, but, you know, would you be okay if I try my new treatment on you? You'd probably go to the doctor and be like, hell no, don't try that on me, right? But with the digital platform like this, like with FEA, you know, you could try something like this and you can actually see what happens before actually putting someone's life in danger and trying something new like this. So having the ability to do simulations and predict what will happen, you know, without having to try it out in real life, that's really, really good. Okay, any questions on this so far? Okay. So, you know, after all this, you know, you can probably think of some examples that you can apply this to as well. I know a lot of you are coming in with you know, from your senior design projects as well. So, you know, I always get a lot of people from the legacy teams in here. So, you know, being able to apply FEA in your design for senior design is a really, really great asset. So actually, I think, you know, I talked to Dr. Lee a lot and know that a lot of people in his class, a lot of students in his class use FEA. So I'm really happy that people are using it more and more for their. Okay. So before we get to the before we start talking about the syllabus, you know, let's just go over very quickly in terms of what the finite element process actually looks like. Okay, as on Thursday, we're jumping right into it on Thursday. So Thursday we're doing our first ANSYS activity. Okay, and so Thursday I will say is going to go really, really fast, and so there's a lot we need to cover Thursday. So I want to at least go over kind of just kind of from kind of a bird's eye view in terms of what we are doing, just to kind of give you a little bit of context. All right, the first step in every finite element process is to define the geometry, okay? So whenever you're going to do a simulation, you know, you need to have the domain, you need to have the subject of your simulation itself, okay? You know, the way you obtain the geometry is, for the most part in engineering, you know, you're going to be using a CAD file, maybe something that you produce with SolidWorks, okay? On Thursday, you know, just because it's a relatively simple case, we're gonna create our own geometry. But for the most part, you know, you're going to be creating your geometry in some kind of CAD software and then importing that into ANSYS. Okay. I get a lot of questions every year because I know SolidWorks is kind of trying to dabble, is starting to dabble in FEA. They have SolidWorks simulations now. I will say, you know, I'm not going to dismiss it right away. I will say I haven't really had a chance to play around with it all too much. But I will say that, you know, kind of where the industry is right now is that, you know, most people still use ANSYS for the FEA. I don't really know anyone that's using SolidWorks for all the finite elements. Just because ANSYS, what I've heard is that ANSYS just has a lot more features. But you know, but for now, you know, I think that the first step is just defining the. Okay, next step is to specify the material properties, and so you need to specify what material your part is made out of. Sometimes you need to specify more than one material, because so if you're importing like an assembly of parts, oftentimes those different parts in the assembly are made of different materials, so you need to make sure you specify that. Okay, and so this is really important because the material properties, things like the Young's modulus, the density, the Poisson's ratio, are going to determine how your part is going to respond to the loading. Right, and so if you took a beam, if it's made out of steel, right, a steel beam is going to be very hard to bend, right? So you can try all you want, but the steel beam is probably going to stay there because steel is a very strong material; it's a very heavy material. Okay, but if you compare that to plastic, right? If you have a beam that's made of plastic, you can probably bend that with your hand, depending on the type of plastic that it is. So specifying the material properties is something that's really, really important. Make sure you get the right ones. Okay. And that's one of the common mistakes that people make. Yeah, question. What's creep? Creep. Creep is creep is kind of the small. How should I describe it? Creep is like the it's like the small deformation of a material over time due to kind of small. So some materials have the property where, like, if you apply lots of small movement over a long period of time, it can kind of elongate and kind of deform, like a windshield. Exactly. Slowly. Kind of. Yeah. so some material properties, so some materials will have that property where, depending on how the material was modeled, you may have to input additional creep. It's related to fatigue. Yeah, so for this class, we're mostly going to be focusing on kind of the simple material properties of things like Young's modulus and density and Poisson's ratio. But just know that there's a lot of material properties that are out there as well. There's actually a lot that we can talk about with materials. And honestly, it's not something that I have a lot of strong expertise in. But the material rabbit hole goes very, very deep. And ANSYS actually has a lot of really robust features for materials as well. But for our purposes, we're mostly going to stick to just the essential features. Okay, the next step. I think this is the step that people have the most fun with, and I think that the step that people most associate with finite elements, which is the discretization step, or also often we call it the meshing step. Okay? So in the meshing step or the discretization step, what we're doing is that we're taking our geometry and we're breaking it up into lots of little tiny shapes. Okay, so you can see here on this image on the right here, we have some kind of gasket. And after the meshing, we've kind of broken it up into all these little kind of tiny boxes. The reason we do this is that, by creating a mesh, by kind of discretizing our geometry, it makes it a lot easier for the computer to solve our differential equations. Okay. And it kind of makes it look kind of cool too, just kind of subjectively, right? It's a kind of a pixelization, you can say, of your view. And so there are a lot of kind of parameters that you can set with meshing. And actually, we're going to spend a lot of time in this class talking about meshing in terms of, the shapes of the elements that you choose, the size of the elements that you choose. There's other properties like the order, the skewness of the elements. So all of that kind of plays a really important finite element results. And so we're going to talk about meshing a lot. Okay. All right, so the next step is to apply boundary conditions. And so after you've applied your mesh, next is to apply what are called boundary conditions. So the boundary conditions are, you can think of them as any kind of external forces that are being applied to your geometry, right? Whether that be external forces or maybe external constraints, okay? So on Thursday, we're going to be talking about the fixed constraints and what it means to fix a particular boundary, the application of pressure loading, application of force loading, right? Basically, anything that's external to your geometry that's going to place some kind of physical influence on its response, we're going to apply that through the boundary conditions. Okay, boundary conditions is another big thing that has a big impact on your results, and so we're going to be talking a lot about boundary conditions, especially kind of in the early parts of them. Okay, so the next step that you don't typically see is to what I call assembly. Okay. So in order to solve the system, the computer has to assemble what I call the global system of equations. Okay, you don't see any, as a user, you don't see any of this. This all kind of is handled by the computer. But just know that this is kind of the math step that the computer does to solve your system. Okay, and so the next step is to solve. Okay, which seems like the most time-consuming step, but this is actually the easiest step for you. All you have to do is just hit a button. Okay. What you'll learn on Thursday is that FEA, if you're going to be performing FEA as a user, you're going to be spending 90% of your time just setting up the problem. So once you've had it properly set up, then the computer actually goes through and solves, which is kind of an inverse thing, which I think compared to your other classes, because I'd say that if you take your traditional solid mechanics, fluid mechanics, you spend almost none of your time setting up the problem. The instructor kind of does that for you, and you spend the majority of your time solving. So with FEA, it's kind of reverse, where you spend the majority of your time setting it up, making sure it's in a form that the computer understands, that it's set up well, and the computer does most of the legwork there and solve. And so you'll see ANSYS kind of makes this very satisfying for you. It has kind of a big button that says solve with a lightning bolt, and then you click it, and then you get a solution. Okay. And what you get after that is the results. Okay. And so the last step in the FEA process, it's not really a step just because the solution's already received. But in terms of engineering design, this is kind of what you're most interested in, which is called I call it the post-processing. Okay. So after you run your simulation, you'll be able to obtain results in terms of what the deformation looks like, what the stress looks like, and it's usually displayed to you and these really nice color contour. Okay. And so if you've ever read a heat map or something like that, or a topology map, you'll feel right at home here, where the colors kind of represent the different values of the different magnitudes of the results. Okay. And so what you're seeing here is a factor of safety. Okay. So for this particular part, they applied certain loads and they wanted to compute the factor of safety. Okay. You can see here all the deep red regions here that has a factor of safety of 7. So that is areas that are very safe. Whereas the regions that are blue, those have factors of safety, 1 or less. Okay. So what this person basically does, he ran a simulation on his part, and he was able to identify the locations of his part where it's most likely to fail, or where the factor of safety is least. Okay. And so by doing this, by looking at these results, he says that maybe I should reinforce these areas, maybe I should add some additional structure there to increase that factor of safety. Okay. And so we'll be talking a bit on Thursday about how to interpret the results and what kind of results. All right, any questions on this? Okay. All right. So the majority of this class, we'll be learning about ANSYS and how to use ANSYS and what the different settings are. But we are going to learn a bit of background knowledge as well. Okay. And so sometime starting maybe around like middle of October, we're going to be learning a little bit of theory on FEA. Okay. And I know that's the time when everyone groans, no one wants to learn the theory, everyone just wants to play ANSYS, I get it. But it's really important to learn the background. FEA, I will be the first to tell you, is a really, really powerful and useful tool. I am the biggest cheerleader for FEA in the department. I love FEA. Okay. But just like any tool that you use in engineering, it has its limitations and it has its best practices. Okay. It's not God, right? It's just a software. And so, it's really important for you to learn, as someone who's going to leave this class and who's going to be an expert in FEA, it's really important for you to really understand its limitations and really understand the best ways to use it. Okay. And you really can't get that unless you really kind of learn the background. Because it's important to know that it's not going to work all the time. Okay. Especially if you set it up correctly. Right? We have a saying in computational engineering that goes, if you put garbage in, you're going to get garbage out. So if you don't set up your simulation properly, you're going to get garbage results. That's just how it is. And the computer won't tell you; it's just going to give you the result. So it's kind of up to you, with your understanding of the theory and the background and the limitations of FEA to really determine whether the FEA result is reliable or not. And as an expert, because right now it's okay for you to make those mistakes because I'm you, and I'm here to kind of give you feedback on your work and tell you whether things are set up well or not. When you get out there in the real world, you're not going to have anyone that's checking your work. So you're going to be the one that's checking people's work. So it's your responsibility as the expert to really understand and have a deep knowledge of the tool that you are using. Okay. So we're going to be going over some background knowledge. There is some hand calculations in this class. There is some theory in this class, but it's important. We need to know that for to use that. And the example I always give is your doctor, your veterinarian. Okay. And so as a doctor, as a vet, you need to know what I call procedural skills. And so you need to know, physically how to administer shots to animals, how to take a blood sample, perform ear checks. But what we expect from our vets is that they should also know conceptually why they're doing these things. Why and when to give animal shots. They shouldn't just be, giving our pets random shots for no reason, right? They need to understand why an animal gets sick, what to do, and even just to interpret any kind of weird behavior, right? And that stuff is more than just kind of using the software or doing the thing. That requires all of the background. That's kind of why we spend quite a bit of time on the background knowledge in this class as well. Okay. Any questions on this so far? Okay, so why ANSYS, right? Kind of maybe not the question everyone's asking right now, but in reality, ANSYS is just one of many finite element software out And so, I mentioned SolidWorks simulation is coming up as well. There's another software that's used a lot in the research space called Abacus, and so that's another great one as well. So why did we pick ANSYS for this course? If I'm going to be real with you guys, it's because ANSYS gives us a free version, and so it's the cheapest one for us to use. But ANSYS is also genius in that sense, is that because they offer a free version, everyone's learning in the schools. And so, when you guys go out there in the companies and you say that finite elements, it encourages the companies to buy ANSYS for themselves as well. So it's a little bit of kind of smart marketing. But because of that, ANSYS is kind of I would say the industry standard finite element software out there. It's the most common one that people use. So using ANSYS in this class, learning it, the idea is for you to learn skills that you can kind of directly apply if you use finite element in your job after grad. Right. Okay, I'm gonna skip this one just because we're running a bit short on time. Are there any questions before we kind of start talking about the syllabus? Okay, so let's talk about the syllabus. Okay. All right, so all of this is available to you on the Canvas site, so you can download the syllabus and yourself. But I thought, for the first day, let's go over that stuff together, just so that we're all on the same page. All right, so let's talk office hours. So my office is in the engineering building, so it's the building that's across the quad. So that is engineering 220. Okay, my office hour times primarily are going to be on Mondays and Wednesdays. So I have Mondays and Wednesdays 5:30 to 6:30 p.m. I also have office hours on Thursdays, so that's before the lectures from 1 to 2 p.m. Okay. So for all of the office hours, I will be in my office, and so I'll be sitting in E220, so you're free to come in person. But you're also welcome to join it virtually as well. And so I have Zoom links that I'll show you on the course website that you can use to join the office hours. And for this class in particular, the virtual office hours is nice because let's say that you're working on ANSYS, you're running into an issue. You can just join on your laptop and just share a screen, and we can kind of look at it together that way. It's a little bit easier than you logging your computer to my office and then that way. So feel free to use both. Okay, course learning objectives, and so I have more of these, and so I have these course level learning objectives to kind of guide and kind of organize the entire course. And if you notice that all of these are they start with the verb as well. Just to kind of demonstrate to you what you should be able to do after the classes and stuff. Okay, let's talk homeworks. And so there are 7 homework assignments planned for the class. So that is 6 ANSYS activities and 1 problem set. Okay, so the majority of the assignments are going to be ANSYS related. Usually at the end of the semester, I have time for 1 more optional ANSYS activity. Usually to teach a more specialized feature that people are interested in learning. But I usually don't grade that last one. That last one is usually just for your interest. Okay. There's 1 midterm exam based on the theory stuff. So that's going to take place around Thanksgiving. 1 midterm project. The midterm project is going to be due around Halloween time, and 1 final project, which is due at the end of the semester. Okay. The homework in this class, a little bit different than my other classes, just because of the nature of the activities. I only grade the homeworks in this class based on completion. And so, I basically just kind of, you turn in your ANSYS activity, I kind of just scroll through, just make sure you did everything, gave it a much effort. Okay. The lowest homework grade is dropped. And so if you miss an activity, you're fine. The lowest homework grade is dropped. But please do all of them, especially in this class where, the majority of the assignments are based on ANSYS. If you skip one of the assignments, then, you're going to be missing out on some important features of ANSYS that you can use. Okay. The third bullet point is not really relevant. I just forgot to take it out. I used to have 2 midterm exams in this class, but lately I've been doing a midterm exam and 1 midterm project. So the midterm exam is just going to be based on the theory. So we're going to be covering theory for maybe about 4 to 5 weeks. So it's not going to cover the ANSYS stuff. It's just going to be on. And then the dates, the due dates for all these things are at the bottom of the screen. So the midterm project, I'm planning for it to be due Friday, October 25th. Midterm exam is going to be on Thursday, November 7th. Push that back a bit. And the final report is going to be due on Sunday, December 26th. Okay. So I have these dates right now just because I'm required to have these dates from the university. But I am pretty flexible. So, it happens every semester. And I promise you, there's no collusion, there's no secret council of professors who's saying, "Hey, let's plan our exams for the same week." That doesn't happen. It just kind of happens that all of these kind of fall at the same time. And so if you guys are really slammed during those weeks and you guys are really busy, just let me know. I'm always more than happy to kind of push things back to make things more convenient. Okay. The only one I really can't push back is the final report, just because we're really pushing up on Christmas at that point. So that's the Sunday after finals week. So I can't really push that one back because I have to finish all my grading before Christmas. And I generally like to see my family and friends on Christmas, and so need to have enough time to do the grading. Okay. So that's really the only one I can't move, but the other ones I'm okay. Any questions on this? All right, course grades, and so this is how the grades are going to be broken down. So the homeworks are worth 10% of your grade. The midterm project is worth 20%. The midterm exam is worth 30%, and the final project is worth 40%. So very satisfying, 10, 20, 30, 40. And then based on your overall grade in the class, your final assigned letter grade will be based on those percentages. I think those are fairly standard. Okay. I have one final bullet point at the bottom that says that I don't do curving in the traditional sense. I don't have any kind of pre-assigned distribution of A's and B's in the class. I honestly think that's ridiculous. But I do adjust the grades at the end. Okay, and the adjustment is always in your guys' favor. So what I typically do is that after everything is into the grade books, what I do is then I compute kind of the overall class average. Okay, so the overall kind of average for the class, and if it's below a certain threshold, usually for an elective like this, usually I like to have the threshold be around like 82% about. So if it's below that, then what I'll do is I'll add points to everyone's grade until it reaches that threshold. Okay. So for example, let's say that the final grade in the class ended up being like 79%. What I'll do is then I'll add 3 points to everyone's grade so that the overall is 82. I will say that I haven't had to do that for FEA. Usually the grades for FEA are usually kind of in the mid 80s, but that option goes. All right, textbooks. So textbook is not required. If you know me, I have the biggest burning hatred towards the textbook industry and the hundreds of dollars I paid them when I was a college student. It's been, I don't know, I think 11 years since I graduated, and I still have that hatred. I'm a very resentful person. Okay, so I never require any textbooks for my courses. Okay, but that said, textbook is kind of an important tool, an important reference for a course. So I do have 2 that I reference for this course. So I have the Logan textbook. That's what I'm going to use for the theory portion of the course, and I have the Lee textbook, which is going to be on the ANSYS portion. Okay. So if you can find these textbooks, they are pretty good. Yeah. So if you can find a cheap version, or what I always tell people, if you just happen to be browsing the internet and you just happen to come across these on a website that you just happen to be on that I didn't tell you to because I'm not allowed to tell you that, so don't idea. But if you just happen to stumble upon one, that's cool too. That's fine. It's like free knowledge, right? But it's not required. Right? So for this class, I post all my lecture notes. I post the full problem statement, so there's nothing you really need to look up. But if you want more detailed information, you want more stuff, the textbooks are always a good reference. All right, course website. So on the course website, we use Canvas. I think the entire campus is using Canvas at this point, or at least I hope so. Okay. Basically, any content that I produce for the class will be posted on Canvas. So that's all my lecture notes, all the lecture slides, homework assignments, ANSYS activities, CAD files. You're going to need some CAD files for some of the activities, homework solutions, exam solutions, study guides. Every piece of course material that I produce is going to be on Canvas. So I always tell people, you should be checking Canvas on a regular basis. At the very least, you should check the Canvas site, at the beginning of the week, just so that you can see all of the material that's going to be posted for them. I'll also be making announcements through Canvas as well, but those get automatically emailed to you, so you don't need to check Canvas for the announcements. Just kind of check their email. Right, and then finally, we have course policies here. So these are the policies that I have in terms of homeworks, regrades, and emails, okay? So I do accept late homeworks. So if you miss a deadline for a homework assignment, don't worry about it, you can still turn it in, okay? You can turn in a homework assignment up to a week after it's due, okay? And the Canvas should allow you to do that. So I've set up the Canvas to still be open even after due date, okay? But the policy that I have is that each day that the homework is late, I dock about 10% of the points, okay? Not a bet, I dock 10% of the points, okay? And if for some reason the Canvas site is down or you're having issues with it, you can always, email me your homework assignments. That's fine as well, okay? So I set the due dates for all the homeworks to be 11:59 p.m. on the day that it's due. But know that, if you're a few minutes late, so let's say that you turn it in 12:30 or like 1 a.m., 2 a.m. I'm usually not at my computer at those times. I'm usually sleeping. So it's not like I'm gonna grade it right then and there. And so if you're a couple hours late, don't stress. I'm usually not gonna take off points in that case. Usually 6 a.m. the next morning. That's about when I wake up. If it's not in by that time, that's usually when I start taking. But there is some leeway in terms of that. All right, regrades. And so, usually not too relevant in this class because a lot of it is project based. But if you do want me to look at something again and want me to regrade something, I'm always happy to do that. Okay. So for this class, it's mostly going to be like the midterm exam, the midterm project. Final project, you don't really have too much time for that, but I've gone back and regraded final projects as well. Okay. So talk to me. I'm always open to that. Okay. And if you want to know the success rate, the people that have come and talked to me and asked for me to look at something again to get more points, the success rate is about 60%. So a little bit more than half. So more often than not, if you feel strongly that you learn more points, definitely talk to me. I'm always happy to do that. But I do place a limitation on this. Mostly for practical reasons. And so, you only have a week to look at the comments that I give you, look at your grade and ask for more points. Okay. And that's a week after I grade something. I do this mostly for the practical reason where, I don't want to get to week 16 and you want me to look back at your ANSYS activity 1 and to give you more points for that. Because it's like, man, that was like 10 weeks ago. I want to kind of avoid those kind of situations. But also, when I grade your stuff, not so much your activities, but your midterm exams, your projects, things like that. I'm going through and I'm leaving comments for you, leaving feedback, and I want you to read that. I'm not just leaving those comments just because it's fun for me. I leave those comments because I think it's useful for you in ANSYS and learning the theory. So I want you guys to read those comments in kind of a timely manner. And so I don't want you to wait until week 16 to look at your grades. Okay. So that's part of the reason why I have that week deadline is for you to kind of read that feedback kind of at a timely manner. All right, and so lastly, emails. And so I get a lot of emails, as part of my job here. I get a lot of junk from the provost in the president's office that maybe 1% of what they send is actually useful to what I do. So I honestly just auto delete a lot of that stuff. But student emails, I prioritize those. I read all of them and I try to respond to it as quickly as possible. So just to kind of help me out, just to kind of filter my inbox, if you can include EGME 410 in your subject line, that just kind of helps me filter stuff out, just so I know that this is my student. That's something I need to read. That's a priority item. And I need to kind of respond to that right. That way I can filter it out from the 24th vice president the provost happened to hire this year that daily operations here. So that's just to kind of help me. Okay. And usually with emails I'm pretty good, so I will get back to you usually same day. If not, then the next day before. Okay. This first week might be a little bit of an exception just because everyone's kind of sending me emails this week. There's a lot I have to do for advising as well, but after this week, if you send me a question through email, I will respond to you as quickly as. All right, any questions on this? Yeah. All right, graduate credit. So I know there's a couple of you in the class. So technically, this course, EGME 410, is an undergraduate level technical elective. It is eligible for graduate credit, so if you're a grad student or if you're an undergraduate that's taking it for grad credit, you can get graduate credit for it. But the requirement that we have that to kind of separate, the undergraduate project from the graduates is that you need to do an extra assignment, okay? So I haven't decided what the graduate assignment is going to be for this semester. But let me know, if you're a grad student taking this course. Okay, I think I know a few of you already. I think a couple of you have already sent me emails. But if you haven't, then just send me. Okay. And that last bullet point there is really only relevant if you're an undergraduate student taking this for graduate credit. So, if you're an undergraduate student here, you're thinking about coming back here for your master's, and you want to get graduate credit for this, there is a form that we have to sign. So, if you're in that category and most people kind of know that they're in this category, just make sure you let me know as soon as possible, because we have to get that form signed pretty quickly. If you have no idea what I'm talking about on that last bullet point, it probably doesn't apply to you, so don't. Okay. All right, last thing I want to talk, or I guess second to last thing I want to talk about with these slides is academic dishonesty. Okay. So let me start by saying that, the university we have very strict kind of policies with academic dishonesty. And so anything from as simple as, copying your friends, activity report, to something more serious to, copying someone's answers on the exam. We have very strict kind of non-flexible policies. So, any act of academic dishonesty will, at the very least, will result in a 0 for that particular assignment. Or if it's on something serious like a project or an exam, it can result in an automatic F for the course. If I catch something, there's really nothing there's really not much I can do. It's a very kind of cut and dry kind of response from the university. Okay. But you guys are all seniors, and so you guys all know this, but the main or kind of the new point that I want to address is the use of AI. Right. So there's been a lot of discussions over the summer, and a lot of discussion recently about the use of AI, ChatGPT, for the use of courses. And right now, honestly, it's a little bit of a wild west. They're kind of letting professors kind of do what they want. And so I'm going to kind of lay out my own policies for AI. For me, it's very simple. I don't allow any kind of AI use in this class at all. Whether that be something as simple as kind of just drafting up your report, or doing your homework problems, none of that will be allowed. And I say this, not because I'm a curmudgeon, although the older I get, the more I'm starting to feel like a curmudgeon, shaking my fist at clouds all the time. But the reason I have this policy is it comes from a place, from someone who's kind of scared of losing his own job to AI. AI is kind of the scary thing right now. It's kind of taking a lot of things. And if you don't think that the chancellor of the CSU system will fire me and pay 20% of my salary to Sam Altman and take 80% of my salary for herself, she would do that in a fucking heartbeat. I guarantee you. It doesn't matter what she said. She would do that in a freaking heartbeat. And so as someone that that kind of fears that will be replaced by AI someday, my mindset and my kind of approach is that, I need to be able to show that I provide value that's beyond what an AI can do. And what I'm concerned about for the future is that, you guys are going to have to do the same. Okay. So whatever company that you end up working with, after you graduate here in 10, 15 years in the future, it may be a constant battle that, you need to be able to demonstrate that you can provide value more beyond what an AI can do. And part of that process, part of providing doing that is learning these kinds of skills, learning to do these yourself, right? Because I'm giving you all these assignments, I'm giving you these activities to do, not because I need them done. I know that these simulations can be done. I've done these before, right? It doesn't tell me anything if you ask ChatGPT to run your simulations or write your report. What I really want from you guys is for you guys to take something away from this class, take kind of real skills that you can apply your next steps, or even just apply to your senior design projects, and really kind of learn skills, right? Beyond kind of what an AI can do. So that's kind of why I have this stance. Part of it is and you can probably tell from the tone of my voice, part of it is personal. AI in terms of that. But you know, I really do think that this is kind of the best way to go about this, is that, you know, if you're in a classroom to learn something, you know, you should really try to do as much of it yourself as possible. Right? As convenient as AI is, and I'll be honest with you, I think AI can probably do a lot of the stuff in this class. Just because, you know, this is a fundamentals class, right? You're learning finite elements for the first time, right? Of course, an AI will be good. You know, but you need to build a foundation somewhere, and this is kind of where you build it. You know, and then from here you can do kind of more stuff. So that's kind of why I have the policy that I have. You know, hopefully, you know, that kind of gives you some understanding where I'm coming from. And of course, that same mindset kind of goes to other forms of academic assignments. Okay? Because the bottom line is that if you're not the one that's kind of manually grappling with material and learning stuff, and you know, you're not getting as much from this class as what you're able to do. All right, any questions on that? Okay, so the last thing in this slide, you know, before we go to the course website, is the first homework assignment, which is introductions. Okay, so the first homework assignment is just to send me an email, just introduce yourself. You know, you're going to get full credit for doing it. Okay. So include your name, your year, your major. Okay, because I like to get to know my students, right? So a lot of you I've known before. I've had you previously as students, so you know, of course, you know, I still remember you. You know, but your life is different now than it was before. So send me an update, you know, see, so, you know, how are you doing and things like that. So, you know, if you're not sure what to write, you know, I have questions here that you can answer. You don't have to answer all these questions. But, you know, if you're struggling to kind of know what to talk about, you know, you can answer these questions. So the due date for this assignment is going to be this Sunday. So if you send me an email by this Sunday, you'll get full credit. I do read every single one and I do respond to every single one. So, you know, so the more you kind of write, you know, the more I kind of learn about you, which kind of makes it, I think, more enjoyable for both of us. Okay. And in your email, don't forget to write, put EGME 410 in the subject. Just so. All right. Any questions on this? Okay. Okay, so the last thing I want to do, you know, before I let you guys go, is to go over the website. Okay. Okay. So this is the Canvas site. So this is what you're going to see when you get online. Okay. You can see we have EGME 410. That is the name of the course. That's my name, my email address, in case you forget. Class times, class location, description. So all of this is kind of, you know, a little bit of a summary from the syllabus. Question in the chat. So just to clarify, are the ancestor activities done during the lecture and the problems are done somewhere? Yes. So the way the activities are kind of structured is that, you know, there's kind of a tutorial portion of the activity where we kind of do it together in the class. Usually that takes up around maybe 45 to 60 minutes of the class. The rest of the class time is meant for you to kind of finish up kind of the problems of the activity. But for the most part, you know, there's going to be some additional stuff for you. Great question. Okay, here are the learning objectives, again, kind of pulled straight from the syllabus. The full syllabus is here for you to download as well. Okay. Zoom links. I think I mentioned that in the first email to everyone, but you are welcome to attend the lectures on Zoom. Okay. So I've been doing this for the past few years, and I think it's been kind of a nice thing. So I'm continuing to do that. Okay. The only day that I require you to come in person is going to be on the midterm exam day. Okay. But for every other lecture, you are free to attend it virtually. And then all the links for the office hours are here as well, the relevant times. Okay, so if you want to attend the office hours virtually, you can do that as well. All right. But I think the most important part of the homepage is the course outline that we have here at the bottom. So if you notice from the course outline here, I've broken up the entire semester into the 16 weeks. And in each of the weeks here, I have a little bit of a title in terms of what we're going to go over that. And so right now, only the first week is clickable because, you know, we're only in the first week of the semester. But as we go through the rest of the semester here, the rest of the links here will become clickable. Okay. Let's click on week 1 just so that you can kind of see what to expect here. So I have weekly pages that are published for each week. Okay, so for each week, you'll be able to see kind of a description of the thing that we're going to do that week. We have the learning objectives for the week. Okay. I have links for the recorded lectures as well, okay? So then the nice thing about streaming the lectures on Zoom is that it's all going to be recorded. And so after the recording is done, I do post it on YouTube and I do. This is particularly useful for the ANSYS activities. Because sometimes for the ANSYS activities, just to make sure that everyone's, just to make sure we finish it, I do kind of go a bit fast. And so if you miss a certain part or if you kind of fell behind, you can always view the recording to kind of help you out. I have all of the assignments here, so you can see that we have homework 0, just reductions. ANSYS activity 1 is here as well, okay? So that's what we're going to do on Thursday. And any kind of lecture notes that we're going to do for the week I have here as well. Okay, so that's the weekly pages. And so I tend to post the weekly pages on the Friday before. So the weekly page for week 2 is going to be posted this Friday, okay? So make sure that you're checking the weekly pages, if anything, just to stay on top of downloading all the files that you need. All right, any questions on this? All right, next tab we have here is the announcements tab. So all the announcements that I'm going to make for the class are going to be stored here. For the most part, you shouldn't have to come here just because all the announcements should be sent to you via email. But in case you want to see the archive of all the announcements, that's there as well. All right, next we have the assignments tab, and so this keeps track of all the assignments. And so from here, you can click on the assignments and kind of get more information about it. A lot of times, a lot of the activities will come with like a PDF for you to download as well, so you can access that from here. And most importantly, you should be able to see the due dates as well. Right? So you can see that activity 1 is going to be due on September 6th, we'll do next Friday. Okay. And you can see that it's going to be available until September 13th. Okay. So don't get these two confused. So the due date is different from the availability date. Okay. So after the due date, if you turn it in after September 6th, I'm going to start marking it late. But the absolute last date to turn it in for credit will be September 15th. Next tab here we have here is the grades tab. And so if you want to view your current grade in the course, you can do that here. So this has all the assignments as well as the grades. And so your total. Right now, there's nothing there because it's, we haven't graded anything yet. But as we start to put grades in, you should be able to see a running total. Next tab is the people's tab. So you can see a list of everyone that's in the course. Next is the pages tab. You shouldn't have to view this, but this is kind of my scratch space for tracking the pages. And the last area that I want to show you is the files tab. So this is where I put all the files for the class. So all the activity briefs, all of the lecture notes, all of the CAD files that we need, the specifications for the project, and solutions, homework assignments, everything's going to go in here. So you can kind of use this, if you're looking for a particular file, you can find it. I do post all these files in the weekly pages, and so if you're kind of following along with the weekly pages, for the most part, you shouldn't have to come here. But if you're looking for a particular file, you can find it here as well. All right, any questions on the course website? I try to keep things as simple and kind of as clean as possible for the website. I don't know what these, SOQs is SOQs, but I don't know what this course materials are elucidated. I'll probably remove them because I don't use them. But the main ones that you should need are kind of the ones that are. Okay, all right, so that's all I had planned for today. So Thursday, we're doing ANSYS. ANSYS first week, that's as early as I can do it, I promise you. So we're doing ANSYS on Thursday. Okay, so thank you guys for coming today. Hope you guys enjoy the rest of your day, and I will see you on Thursday. Thank you.
Or is it? But then I'd rather that's all I'm saying. Yeah. I'm just taking it.
I'll give you one.
Okay, thanks.
Yeah, so,
Yeah, I know, man.
So, I don't know, it seems like.
Oh, you still good thing, I guess.
Oh,
You can stay with me. Wow, I walk it. Watch me for up.
Oh, yeah.
Oh, you in?
Yeah.
Oh, you first and third.
He's.
I know, so.
I have.
Because you guys told.
No, I'm just here to ask.
Yeah.
You guys had a meeting.
I think we don't try to make it with you guys.
Yeah, I'm third.
But, yeah, it's almost kind of a lot of things. But we are.
I know. That's probably on my. I'm just.
I will give you guys.
No, I already in his econ. It was like two wait, listening.
Just send me the homework.
We'll see.
It's the weirdest thing. I'll forget over.
We'll see.
Yeah. Yes.
Oh, hey.
It's like a.
So I can say top five. I think you're pretty safe. I would. Kind of on the borderline. So the thing that's kind of complicated that they have another elective that's considered.
So you're, well, yeah.
So that one is from.
Oh, yeah.
Oh, yeah, I'm really lost. That one's designed to talk about. So I've been telling people if you're kind of far down the list, 7, 10. So that meant actually right now, so that they're. You're pretty safe. So it's, I'd say you're pretty safe, but you know, but. Just prepare, just be prepared.
I think we'll go back.
Yeah, so 490 is right now, so that's, so they count one, so the three pounds that we have. now-
No, it's pretty good.
Okay.
Just a lot of bad. Well, a lot of bad. Yeah. No, I'm done. I'm super happy you're
No, you probably.
I probably would definitely wait a minute. But with my dad, it's not me. I'm not saying it. I don't. You got it.
That's great. How many hours?
Like as long as I put it on what is equal to 1 second, I can.
Okay.
As long as I'm.
That's it.
Oh my God, I don't mention it to myself.
Yeah, I don't think it's. It's like 2 or 3. Wait, what is it? Like, why? I actually don't know.
That's kind of funny.
Because I guess I'll see you later.
Well, they may look at your transcripts. See.
Yeah.
No, they were also. She does the side and he's.
That's my sections. It's usually like 20 people to the section, but this time they came last to 16.
Who's speaking, but online it's still 20.
So, yeah, I'll try to do
Kind of shows.
Yeah.
Like last time I've been people, you know,
this. We also have to.
I guess it went by some students. I think like.
It's
So there's that's going on.
They have a lot more.
City time that has open seats. It's like design.
There's a lot of moving pieces. I'm definitely looking for. Especially because it's still.
That's good to you. Today.